Okay, so for another video here, we're going to be taking a look at a table, so a little bit different of what we've been seeing before. And this table is kind of relating, again, two different sets. Now, this is a kind of a more, let's say, of a mathematical relationship, but we have number of marbles here, and they're denoting the variable n, and we're going to say that the mass of the marbles, m, is measured in grams. So a couple things of how we even read this table is that we want to make sure that we have the title, of course, and that's pretty easy to see. But we're talking about units here, or sorry, the variable here, and then the units that come afterwards. So this is our variable. And then the units are always always measured off in brackets. They're always put in brackets here. So this is going to be our units. I should not use white for that. Let's use a different color. I'll use red again. This would be units. Okay, so just a little bit about how to read a table. Shouldn't really come as a shock for you, so that's okay. Again, we have our first column here. This is our first set, and all of these values here, these are all going to be represented as our domain values. These are domains. That's always on our first set. Later on, this becomes our x values. We'll get to that later on in the unit. All of the things in our second column, or our second set here, they're going to be our range values. Okay, so first off, we want to just kind of take a look at some of the things that the table tells us. It looks like our domain values are going up by 1 each time. So 1, 2, 3, 4, 5, 6, which makes sense because we're talking about number of marbles. It's always nice to kind of talk about could there be things in between them? If you remember from grade 9, that was called interpolation. And there really shouldn't be here because we can't really have half a marble. Well, I mean, technically we could, but in this table, it doesn't really give that option of we can have a mass of a half a marble. I wouldn't even know how you would split a marble exactly in half to measure half the mass of it anyways, right? So in this case, we're only going up by whole numbers here. And the mass of our marble looks like it's going up by a steady amount as well. Less important over here, but domain is really the name of the game, and we want to make sure that we know what's going on. But let's see if this relation, which relates number of marbles to the mass of the marbles, is a function. So I just kind of want you to take a look at this, and you can imagine drawing arrows in your head if you'd like to, but really just based on observation, you should be able to see that there is no repeated domain value here, where the mass of one marble is repeated to have to be basically repeated to get back to the same the mass of the marble or the number of marbles, right? We don't have any repeats here. For this reason, we know that this is going to be a function. Later on, we'll come up to a certain type of test that we can perform on a graph to figure out if a relation is a function. But for right now, function. And I always like to just kind of say there's no repeated domain values. I think that's a pretty easy and concise way to say it. So it's, of course, a relation, but there's no repeated domain values. We don't see a double spoke of 6 going to do 2 different masses. Like that doesn't exist here. It wouldn't really make sense anyways. So that's good. Let's go ahead and let's talk a little bit about some variables. So we've talked about different variable choices in terms of n and m, and that's just how we read the graph. But we do need to know that since this is domain, since my first column is domain, then that means that this is going to become my independent variable. So first column always follows that this is going to be my domain. These are my domain values. But also, these are going to be my independent variable. Of course, if it's noted for you. Independent variable. And that's my cat. So in this case, it's already made for us, so we can just kind of say that our independent variable is equal to n. That's all it is. It's there for us. If we had it to make one, I suppose we could, but it's there for us, and we already kind of know that. Kind of by this logic, we can say that our second column is going to be our range, right? And we're just kind of looking at the opposites of everything I've written down over here. And that's, of course, going to be my dependent variable. And in this case, it's already done for us. They've chosen that for us. We could make one up if we needed to, but that's going to be m. it's really important for you to know that it's not G. G is our units, okay? And that's measured in parentheses, as you can see here. So justify the choices. Well, in terms of justifying, right, this means that, okay, well, why is that the independent variable? It's kind of a lame justification if you say that it's just in the first column and Mr. Morris told you so. Think about the relationship between these two. What does the mass of the marbles depend on? Well, of course, how many marbles you have. I suppose you can think of the argument of like, oh, well, it depends what kind of marble and how big the marble is. But we're kind of just saying that these are identical marbles. The question's kind of already thought about that. It's identical marbles. So it's really just how many marbles that you have. Marbles you have. And it's just really putting that down in logic, right? So how many marbles you have is an independent variable. That's independent of everything, right? That doesn't depend on anything. It's completely independent. But the mass of those marbles is dependent on how many you have, right? So just kind of being able to justify that and going through in your head should be pretty easy. We've been doing that since, probably since grade 9 and before that, just kind of saying, okay, what's dependent on what? So that should be a pretty okay justification. Let's really talk about this domain and range. Domain and range is something that we're going to be doing over and over and over again, just like my cat. So we're going to go ahead and we're going to kind of describe what the domain and range is going to be. And this is going to change throughout the course depending on, if we're dealing with real life examples or if we're dealing with like a general example or like more of a pre-cal type of a topic. So domain and range is something that's pretty fluid and it's going to change for us. Let's go ahead and let's get the domain here. Now I'm going to assume something here. I'm going to assume that our data stops after 6, but I'll show you what you can do if the question indicates that maybe it's going to go on a little longer. So we're always going to use our braces. That's our like funky little brackets that you see here. And now we're just going to start to list off our domain. But here's the thing. You want to go from least to greatest. So the number that's the lowest to the number that's highest. Our table is conveniently in that already. However, if it wasn't, we would need to make sure that we put our number that it's the lowest first, second lowest, third lowest, all the way up to, second highest, first highest, that kind of stuff. And we see this. So this is kind of taking into account that the data that we have is only up to 6. Now, it's not a big deal, and I don't really care too much about this, but if this data was to continue on for forever, and maybe the question even said that in it, what you could do is you can just kind of put these 3 little dots. They're called ellipses, and you can just put these 3 little dots here that mean, oh, I'm just going to continue on forever. So if we wanted to put this all in, let's just see what that would kind of look like. I would, again, put my comma, and then what I could just do is ... and then close my bracket off. You could include this, you could not include this. It doesn't really matter to me, but if you do see it, that just means that this is going to continue on forever in the established pattern. So 7, 8, 9, 10. We're going to talk about what type of unit system this is later. This is called the whole number system. We'll talk about that a little bit later on. Not too important for us right now. Let's go ahead and let's get the range now. Now here's the interesting thing about range. Range is exactly the same way of listing out as the domain. It's going from smallest to highest. It is not like ordered pairs where I have to have one that goes with my first range entry. The first element of my range and my range should just be the lowest value that I see. It happens to be the one that pairs up with one as an ordered pair, but that's not necessarily always going to be the case. Always use lowest to highest, no matter what you're going at. I'm going to run out of room here, so I'm just going to kind of continue on. This is kind of bad math, but that's okay. I know that you'll forgive me. 6, 5, 7 point. And again, if we wanted to, and I really don't care too much about this, but if this were to continue on, we would just put the 3 ellipses or the 3 dots that shows that, hey, I'm just going to continue on this on forever. And that would be our range value. So domain and range is something that is our first set. All of the elements of our first set, we see 1, 2, 3, 4, 5, 6, continues on forever if we need to. And range is all of the entries in my second set, again, lowest to biggest. And if we are going to repeat it, we would put the ... and that's going to be our range. Domain and range will change in the future when we start to look at different things like equations and functions and all this kind of stuff. By the way, this would be a function. We already kind of represented that. There would really be no way for you to determine if this was a function from the domain, because we would never repeat entries of domain and range. Never repeat entries. Either on domain or in range, we wouldn't repeat those entries. So it's very, very hard to us to determine if, just based upon domain and range of something is a function. You really need some more information, like a graph or a table or ordered pairs, something like that. But I just wanted to kind of take a chance and talk a little bit more about this domain and range and functions. And yeah, that should be good for this video then.